All right, as we just finished up talking about exponential growth, today we're going to talk about something a little bit different than exponential growth. We're going to be talking about exponential decay. And when I talk about exponential decay, the one thing that comes to mind for me is bananas. When I think of bananas, and I think about how a banana starts out nice and yellow, and as it sits on my countertop, eventually goes to gross looking brown, right? And if I just left it sitting on that countertop over time, it would exponentially get more and more brown and more gross and more fruit flies would be flying around my exponential decaying banana. The other one I always think about is the exponential decay that goes through when I am looking at a deer that gets hit on the side of the road. So an exponential decay function is y equals ab to the x, where b is less than 1 and greater than 0. That decay factor is b. So how much is this thing decaying? What I always talk about is how much of its life is it keeping. So if it's keeping 80% of its life, it's decaying 20% a day. So it's 80% of each day, right? So if you started out with a whole banana and it decayed 20%, you'd have 80% of a banana, and so on and so forth. Let's take a look at the parent function for exponential decay problem. The parent function for an exponential decay would be y equals b to the x. The domain is, remember, all real numbers, and the range is y is greater than 0. And you'll notice how that thing goes whoop, right down here, and it has an asymptote of that y-axis. It's never going to touch the y-axis. So if I take a look at example 1, and I plug 0 in here, 3/4 to the 0 power is 1, so this is just -2. And I put 1 in there, I end up with -2 times 3/4, which is going to be -1.5. And so because this is negative, it's going to be upside down of my parent function. It flips upside down. And so I graph 0, -2, 1, 2, right there. And I graph 1, -1.5, right there. An exponential decay function that is flipped kind of looks like an exponent, it's going up, it's not going down anymore, but it's because it's flipped upside down. From the left to the right, draw a curve that begins just below the x-axis. So we're drawing, they wanted me to draw this from the right to the left, which we normally draw from left to right. Begins just below, because it was flipped, below the x-axis, and passes through the 2 points and moves down to the left. Like that. All right. Let's take a look at example 2 here, and we got some checkpoints coming up. Be ready for those. Y equals 2 to the 3/5 power. So I always think of that it's keeping 60% of its value. 3 divided by 5 is 0.6, or 60%. And we have a shift here. We have the h and we have the k. And it's just like the exponential growth problems that we did, where this thing is going to shift to the right 1 and up 1. Right 1 and up 1. So I'm going to graph this original, kind of the root function there. And I have the point 0, 2, and I have the point 1, 1.2. Okay, so 0, 2 is right here, and 1, 1.2 is right here, and then I drop that down, and there it goes. Exponential decay. We'll never get to 0. We'll get close to 0, we'll never get to 0. Then we translate the graph the graph 1 to the right and 1 up. All right, because that's a -1 and it works, the h works the opposite of how you might think. It moves to the right 1. Because it's a +1 here where the k is, remember the hk, it's going to go up 1. Notice the graph now passes through the point 1, if it moved to the right 1 and up 1. So we add 1 to the 0, 1. We add 1 to the 2, 1, 3. If we add 1 to the 1 here, I get 2. If I add 1 to the 1.2, I get 2.2. So I now have 1, 3, 1, 2, 3 right here. And I have 2, 2.2, 2, 1, 2, 2.2. So it just moved to the right 1 and up 1, and my new asymptote is going to be 1 up from where it was. So the graph's asymptote is the line y equals 1 now. And the domain remains the same, just all real numbers. And the range would be y numbers greater than 1 because it's above that asymptote line, y equals 1. You guys go ahead and take a look at 1 and 2. Go ahead and do those and graph them real quick. All right, let's see what you got. Y equals -2 to the 4/5 x. Maybe you wanted to do that on your calculator. Maybe you thought that would be an easier way to do it. You can make an XY table if you want. Some people like to do an XY table. So I'm going to make a little XY table. 0, 1, 2. Just graph a few points. Put 0 in there, I get -2. I put 1 in there, I get -8/5, which I think is like -1.6 or something like that. And if I put a 2 in there, I end up with 16/25, which is a number I'll probably need my calculator for. So let me grab my calculator real quick, turn it on, and let's see if I could do this on my calculator. -2 to the 4 divided by 5 power all to the x. Now watch what happens. Graph it. Looks like it was flipped upside down. Goes up here just like that, right? Now, watch what I can do though. I can hit second table and I can look at my table. Remember that table I was making? It already made one for me. So then I just plot those points. The other thing I could do is I hit trace and I can trace all along that graph where it's going. And then I just plot that graph. Let's take a look at it, checkpoint number 2 real quick. I'll do that on my calculator. Y equals, clear this one out, 3 times 2 divided by 3 to the, and make sure you put parentheses around this, x plus 1 power minus 3. I graph that. And it looks like it experienced a shift of to the left 1 and down 3. And then I can hit my table, and there's my table. So I can just write down those points and plot them over here on my graph, and you'll be looking very sharp, very sharp. All right, let's take a look at example 3 here, and then it looks like you got another checkpoint coming up. In example 3, clear that out. Let's change to green. Televisions. A television costs $1,200. The value of the television decreases 21% each year. That is the truth. Every time you buy a TV, as soon as you buy the dang thing, as soon as you walk out the door, it's worth less money. So my decreasing value is going to be represented by $1,200, and how much of it does it maintain? 1 minus 0.21. That's how much it keeps its value. So it's only worth 79% of what I paid for it just a year later. All right, and write an exponential decay, estimate the value after 2 years. All right, well, we're going to go to the second power, and then use the graph to estimate when the value of the televisions will be $300. Well, that initial amount was $1,200. The R was 0.21. My equation was 1200 times 0.79, right? To the t, or to the 2 years. We could put to the 2 years. So to the second power. I'm going to grab my calculator real quick and do. I'm going to clear out of this. I'm going to second quit, and I'm going to do 1200 times 0.79 to the second power. Enter, and I get 740. 2 years later, my $1,200 TV is only worth $748. So I got $748 right here. That's all it's worth. Now, the other thing is, what about graphing it? Well, what if I graph this thing just like this? Right on here, and I did $1,200 TV to the 0.79, or times 0.79 to the X power. Well, when I graphed it, I could see exactly what happened with the TV. I would look at my graph over here, though, and see, okay, look, I better fix my window. I'm going to have my Y's go all the way up to $1,200, which is what I paid for my TV. And I'm going to have my X's go to 10 years, but it wouldn't make any sense to have a TV for negative years. And I'm going to leave that negative there because I want to have a little buffer down the bottom. And there's the graph of what that thing's going to look like. Now, when I look at that graph as it goes down, what information could it tell me? Well, could it tell me if I graphed y equals 300, where those two things are going to cross? Yeah, right there. I can calculate an intersection, first curve, second curve, enter, at 5.88. After about 6 years, it's only going to be worth $300. So I can write right here, 6 years. There you go. Now, there's a lot of other ways to do that, but right now that's the only way you have. Later on we're going to learn about logarithms, and that way you'll be able to tell me exactly what that is by hand, not by graphing, and you'll have to demonstrate that on the test. Okay? You guys go ahead and do that final checkpoint number 3, and we'll talk about that tomorrow. Let me give you the answer on that real quick. It's going to be about 11 years. So if you got 11 years, then you got the right idea when it only decreases by 12%. So hopefully you got 11. We'll talk tomorrow. Thanks, folks.